Good morning, this is your Stat Sensei, Mr. Spensei, and this is an assignment, and we're going to do a hypothesis test for a two-sample proportion. We did this as a confidence interval already, so now we're going to do the hypothesis test part of it. A large national bank is considering expanding its investment in mobile banking services to enhance accessibility and customer experience. As digital banking becomes increasingly vital, understanding usage patterns across income levels is essential for making strategic investments that benefit all customers. Lower income customers may rely on mobile banking due to limited access to physical branches or time constraints, while higher income customers may use it for convenience. Identifying differences in adoption rates can help the bank allocate resources effectively, improve digital services, and bridge potential gaps in financial access. The bank serves approximately 350,000 customers earning below 50,000 per year. So this is our first population. Population one is 350,000, and that's for earning less than 50,000. And then we have a second population, 420,000 customers earning more than 50,000. So population two is the group earning more than 50,000. To analyze usage differences, the bank randomly sampled 180 customers from the below 50,000. So N1 is 180,000. And and 220 from the 50,000 or more group. All right. The results show that 135 out of 180, so 135 out of 180, earning below 50,000 would use it, and versus 140 out of the 220 for the other group. So this is our X1. Our X1s was 135 out of 180, and 140 is our X2 out of the second group, of the second population. All right, so we're going to need to take a look at what we found from the data, and what we have is 135 for X1. This is the less than 50K, and this is 140 out of the 220. This is the greater than 50K. That does not look like a 50K, but there we go. And we need p hat 1 and p hat 2. P hat 1 is 135 divided by 180. Remember, p hats are just x divided by n. So that 135 divided by 180 gives us 0.75. Is 0.75. And then for p hat 2 or sample proportion 2, we have 140 divided by 220. And the reason we knew this was a two sample proportion is because we had two separate groups, and nowhere in there does it mention means. We have parts of groups, and so because we have two parts of groups and two samples, two sample proportion. All right, when we go to draw it, they asked us at alpha equal 0.05, do the data suggest provide convincing evidence of a difference in mobile banking usage between income groups? So we're looking for the difference. Well, the interesting thing about that is let's go ahead and we'll come back to our drawing in a second. Let's go ahead and look at what our hypotheses are. Well, the hypothesis is that P1 equals P2, or the alternative is that there's a difference, which we always use the not equal sign for. And we could have written this like this, or HO P1 minus P2 equals 0. The alternative would be P1 minus P2 is not equal to 0. And the reason that is if I subtract P2 from this side, P2 minus P2 is 0. And I have to subtract to this side. It gives me P1 minus P2. And basically, if there was no difference, if I subtract them, it's the same. If you have $5 and I have $5, there's no difference in the amount of money we have. We subtract the two, we get 0. So We said difference, no difference. So we're looking for the not equal to, which means we have a two-tailed test, which means we have to shade both tails. And based on the fact of no difference, we have a 0 right there. That's what we're centered on. And that really is P1 minus P2. Notice it's P1 minus P2, not P hat 1 minus P hat 2, because that's going to come into effect over here. Because it turns out if we take 0.75 minus 0.6363, we end up getting 1137. So P hat 1 minus P hat 2 gives us 1137, and that's where this value is right here. This value right here is 0.1137, and that gives us that difference. All right, well, the next thing we need to do, because we're working with a hypothesis test, we're going to have to calculate something called P hat C. We're going to have to combine them. So we're going to combine X1 and X2, so 135 plus 140, which we have right there, and then 180 plus 220. So let's do that real quickly. 135 plus 140, and then we have 180 plus 220 as 400. So 275 divided by 400 is 0.6875. And so that's our P hat C. And that's super important because that's part of our formula. And the reason we do that is because the reason we do that is we assume that there is no difference. And if there is no difference, then we should combine both samples to get a more accurate measure. Because obviously 75 and 63 aren't the same. So if I combine them together, I'll have a more accurate measure. And the reason why is a bigger sample, more accuracy. All right. Or we decrease the amount of sampling error. So we have sample proportion 1 minus sample proportion 2, and then over the square root of P hat combined, which is that, 1 minus P hat combined over 1 over N1 plus 1 over N2. So when we go to plug in, sample proportion 1, 75%, minus proportion 2, 63.63. P hat combined right here, 1 minus P hat combined, 1 over sample size of 180, and 1 over the sample size of 220. We're obviously running a two proportion z-test. Because it's a two proportion, we have to define two parameters. Now, we did this in a previous video. I talked about it more there, but I am going to put it up so you can see it. We said let P1 equal the true population proportion of mobile banking users making less than 50,000, and P2 is the true population proportion of mobile banking users making more than 50,000. All right, now that we've done that, we need to do our conditions. Well, first part was we need two random samples to be two of anything, we need to have two random samples. Well, we have a random sample of 180 and another random sample of 220. So we have two independent random samples, one of 180, one of 220. So the first part is taken care of, two independent random samples. Then we need to make sure that our samples aren't too big. All right, so we're going to have to compare our sample sizes to the population. Well, our population for under 50,000 was 350. So we're going to take the 180 from our sample size and multiply it by 10. So that's N1 times 10 is 1,800. That's definitely less than 350,000. So this sample isn't too big. When we go to the other one, we had a sample of 220. 220 times 10 is 2,200, and that's less than our population of 420,000, so that sample is not too big. Well, now that we know that our samples aren't too big, we need to make sure that they are actually large enough. Well, to be large enough, we have to use the P hat combined. Please, please, please remember, if it's a hypothesis test and it's two sample proportion, we're going to have to use P hat combined. And we calculated P hat combined up above to be 0.6875. I'm going to write that down here just because we're going to need it. P hat combined equals 0.6875. So in this case, we have 180 and we multiply it times our P hat combined and we get 123.75. That's definitely bigger than 10. So this part is large enough. So now we need to check the other part. And we're going to go 180 parenthesis 1 minus 0.6875. And we get 56. That's also greater than 10. So this part's big enough. Then we're going to go 220 parenthesis 0.6875. Large enough. And then 220 times 1 minus P hat combined. And that's 62.5. So both samples are large enough. So now that both samples are large enough, we can go ahead and run our test. Okay, so this was a 2 proportion. And remember, we said it was a not equal. So let's go ahead and put our data into our calculator. So stat test, we drop down to 2 proportion z test, which is number 6. And we have 135 and 180, 140 for our x2, 220 for our sample size 2. We need a not equal. And we have 2.439. Now, we have to be really careful with this. Remember, since we ended up with a positive z-score, we're going to have to put a greater than sign. So we have that. We have a 2.439. That's our z-score. Our p-value is 0.0147. But remember, even though I have it as one tail, this is a two tail, and anytime it's a two tail test, I have to put them 2 times outside. So 2 times p, or just 2p, gives me that. Well, 0.0147 is less than our alpha, so our decision is to reject the null. Okay, now that we've gotten that far, we can go ahead and write our conclusion up. And remember, we're just starting off with this block right here. Our p-value is 0.0147, which is less than our alpha of 0.0500. We reject the null. Our p-value is 0.0147, which is less than our alpha 0.050. We reject the null. There is enough evidence. There is sufficient evidence to suggest the true population proportion of mobile banking users making less than 50,000 is different. Now, where did that different come from? That different came from our alternative statement. So don't forget, this came from HA. Different than mobile bankers making more than 50,000. All right. So true population proportion of mobile banking users making less than 50,000 is different than mobile banking users making more than 50,000. True population proportion of mobile bankers making less than 50,000 and then making more than 50,000. So both of them, these are restatements of my parameters. All right. This is just a restatement of the parameter. All righty. I hope that helped. Look forward to seeing you on the next one. Thank you.